Glad to see you again for episode 8 about the complete renovation of a small rundown house abandoned since the 1980s, less than 50 square meters. I installed a Thermo-Aero Maxxis thermodynamic water heater without exterior ducting. I'll soon explain why we use a small 50-liter water heater for hot water recirculation, since the pump will be installed here. But here underneath everything is ready to connect it. The small EcoBull anti-scale system and the Grundfos Scala 2 booster pump to increase the pressure and maintain the pressure in the system. And now you might say, do we really need all this for less than 50 square meters? You'll find the answer in the last episode of this series. If you want to watch previous episodes, there's a playlist link in the description. You'll have all the episodes from the demolition up to this one, including the part about the drains that were completely rotten outside. We had to dig and redo everything. So in this video, we're going to focus on this setup you see in front of you. We're going to start from the water supply and create everything from scratch. A vertical comb that I place like this, it supplies this one. And the second one that I was missing, we place it here. So now it supplies this row. I'll remove it now so you can see what I'm doing. The neutral is on the left, marked by the letter N, so the phase is on the right. We take a blue wire, which represents the neutral in 16 mm2. And we're going to put it in, there we go, here, and I'm going to wedge it behind, so it holds by itself. So there, it fits in properly. We're going to make sure it doesn't move, it needs to stay like that. Perfect. We do the same with the face. I took red, it could be brown or black. We put this in there, and I'm going to wedge it in the chute. There we go, I get my comb back, which I haven't lost. We place it like this, we press down, and then we do the same for the other two rows. We screw them in. Under the panel, I have a blue terminal block for neutral, powered by a 16 mm2 wire. It's usually connected from the main panel, but currently the main panel isn't connected. I connected directly to the linky for now, and later we'll do the main panel. So I take my 16 mm2 wire and put it here, but I could put it anywhere because this terminal block is always powered no matter where you choose to connect it. Well, just like its buddy, we'll place the neutral at the top. If I flip this residual current circuit breaker back up, I get the light back in the garage and my small outlets. Since in the previous episode, we installed the Schneider Gain Technique Lodgement, the Schneider Resin Off XZ panel. So XZ for plug-in with the bus bars and the circuit breakers that you plug in directly. Same for the residual current breaker. They plug directly onto the bus bar. Same for the outlets. Another advantage is you don't need to put a comb on top. First of all, it's super fast. It's neat. And on top of that, you can remove, for example, this one right in the middle. I can take it out and it doesn't affect the others at all. I don't have to say to myself, oh, shoot, I have to take up a whole row to remove the comb to work on it, for example. With this system, once you've tried it, you don't want to hear about anything else. To recap, I have a 10 amp for lighting, a 16 amp for outlets, and another 16 amp next to it. Possible causes include a pump, a water heater, another water heater on a 20 amp second pump, or the eco bubble system. Also, the gate below. I put in some outlets, it's convenient. In a garage, we have outlets right in the middle of the panel, and this board, it's pretty handy. So this 16 gauge wire that goes into the conduit, it goes back to the main panel. You get it, that's it. The blue 16 gauge wire supplies the neutral terminal block, and the brown 16 gauge wire supplies the phase terminal block. And here we just put a blue 16 gauge wire and a red 16 gauge wire on top. So connected again to the phase and the neutral, this residual current circuit breaker is powered and supplies via the vertical bus bar another breaker, which then powers a third residual current circuit breaker through the same bus bar. Well, look how neat it is. We don't have to use 16 gauge wire every time because it takes up space. No need 16 gauge. See, if I film it like this, notice how much space it uses on the panel. It's much neater. I'm not connecting the grounds for now. I'll explain why. So this is the 16 gauge wire that starts from here to supply the ground terminal and all the grounds for the water heater, the pumps, the outlets, etc. So I'm not connecting the ground for a very simple reason. I have a doubt. I'm going to put the ground rods here. So in the hatch I made to access the drains, that was in episode 2, 3, 4. I don't remember now. So I removed everything, dug to fix the pipes, and tried to start fresh in the house. Currently, there's an extension cord for the projector to light me up since I had cut the power. Now, with lighting and outlets here, I no longer need the extension cord and can remove it. I told you I want to put the ground rods here, but I have doubts about the water supply. It goes like this. Because the meter is over there in the street, so it must make a loop, but what if I put my ground rod? And with the luck we have in this house, we might hit the water supply and then it's over. We'd have to enlarge the hatch, dig, because the water supply is much deeper. It's going to be a nightmare. I set up a small rig with the tripod and camera, balanced halfway on the dashboard and steering wheel. At the first turn, everything's going to fall apart. I forgot the suction cup to stick it to the windshield with the articulated arm. It was simpler, but I forgot. So I wanted to go to a supplier to pick up some plumbing fittings to start the job. That way we could talk during my 10-15 minute drive. We need to proceed with the installation. Water heater to run lines, connect them at the panel on their own circuit breaker. So we have 2 water heaters connected, and then we'll install all the small pumps. So we're going to open it up with a utility knife neatly. So this is the Thermo Aeromax 6. It's a thermodynamic water heater made in France, the monoblock thermodynamic solution. So it's a monoblock water heater. Ducted ambient air. For me, it's not outside air, just ambient, since the space is large enough. If you have a small space and you put your thermodynamic water heater in a small space, you need to duct it to the outside. If you put it in a garage and it has enough volume, I'll show you the required volume. You can, of course, place it in the garage without ducting it. Hey, that makes for a big cartoon. For the cost paradise, when I'm in the way, it's pretty convenient. You have to check what's in there. Make sure you don't forget. And for example, here, hop. We have some accessories, so you have to check everything. And be careful with the box cutter. Same as always with the box cutter. We didn't use a box cutter. We didn't go scratch the water heater already and then cut something, for example, the petrol. Yes! What interests me is that the electrical supply, for now, I don't even know if I told you that it's 240 liters. So it's a Thermo Aeromaxis monoblock thermodynamic water heater with 240 liters. We have the small accessories here. Let's take a look around. I think it's beautiful with its anthracite gray front panel, really nice. And the Thermo logo right here, the small screen that will light up in a moment. You have to plug it in, of course. And on it, you'll be able to set the off-peak and peak hours. And that's it. Depending on your electricity contract, you can check at the top of your bill. It usually lists off-peak and peak hours and their start times, so we can tell it when to heat. Start at 11:30, post-meridian to pay less, since heating begins then, and we can set the temperature. You can set it up any way you like, we'll cover that soon. Here, we have a little sticker that tells you it's a smart water heater, and there's an app. We'll see how it works with the app. Also, the Thermo Aeromaxis 240-liter specification sheet is here. That's good. Hot water, cold water, the mandatory safety group connected to the drain. Same for the condensate. You have to connect that to the drains, plug it in, of course, otherwise it won't work. Here, we have a nut to remove, the small bracket that needs to be put back with the screw. We screw it in there and then fix it to the floor and it doesn't move at all anymore. They provide what you need to cover it for the outside, so everything is included in the small box. We had an extension, so it's just for the condensates. If you need to drain them to the outlet because your outlet is very low, you'll be able to extend it. With the piece of pipe that's right here, the clamps, the manual, the electrical connector, everything is provided. Now you just have to connect it and it works. We've seen the side and front, and here there's nothing, so nothing like connectors or pipes will get in the way. It's smooth and clean, but be careful passing through, especially with a wheelbarrow or placing a water heater by a door. It can be hit, so protect it on the side and cover the top, as I said, toward the outside. I don't need to. I have enough space. I have more than 20 cubic meters, so I don't need to cover it. I moved it from the wall, as I said. We have enough space and could move it more, but it needs room to breathe. Also, being able to access all sides is useful for maintenance. If you ever want to repaint your wall, you'll be glad to have the roller, brush, or paintbrush so you can paint easily without worrying about going around it. So make sure to move it over. We'll even move it a bit more this way for now because we're going to go step by step. I need to repair the water supply to the wall, then install the booster pump. As I said, we'll go step by step so you can see everything. So, to start, I'm going to put a clamp here to secure the water supply properly, and then above, the same thing, it will be fixed. Geberit clamp features double threading, 8 mm and 10 mm, allowing use of both 8 and 10 mm threaded rods. So here, we're working with drywall, so we'll use an expansion anchor, of course, with 8 mm threading. You really need to use pliers to expand it. There you go. We've got something pretty solid here. There you go. There you go. So I can take this off. I'll keep it. It might come in handy. Here's a washer, a piece of threaded rod. Here I put a nut, so we fix this in there and we'll figure it out. I still need to screw it in. Not bad there. Let's tighten this. I'll tighten it later since it presses against the wall. Then, once we have the right depth, we screw in the clamp, so 8 mm or 10 mm. As I said, it doesn't matter. We'll tighten the nut, of course. After that, we open it, we put the water supply through, we lower this, and there you go. That's how it looks. So now we need to screw it in here. So all of this is fixed. The sheath is good. We have some play in the back with a 13 mm wrench. Next, we're going to tighten all the clamps. So now you've seen how to put on a clamp, I won't film it for you. The others will be exactly the same principle. I raised the water supply slightly, not by much, but it's still something because in the end, when I put the clamp on, I didn't notice it had dropped. But at least I brought it back to the garage. That's very good, but if I can gain a little bit of height, that's even better. Here, we're going to put a brass T heading toward the house, toward the garden faucets, and we're going to install a valve to shut off all the garden faucets, so a brass T. Teflon tape, that's perfect, it works really well, it replaces fiber gaskets, and it's super reliable. Of course, it comes in 1/2, 3/4, 1 inch, all sizes, so I'll tighten it with the wrench in a bit. For now, I'm setting up my little assembly. We put a gasket on top, an anti-pollution valve to prevent stagnant water in the garden faucets from flowing back into the system. Alright, we put a gasket back on one, and my main valve for all the garden faucets. So here it's closed, I open it, and I have water at all my garden faucets. I close it, and it doesn't go back into the system, and so not towards the house. I could reinstall a backflow preventer, but it would be useless. I already have one on the system, at the meter in the street, and the system we're going to install, EcoBool, already has a check valve. So we're going to put the Geberit flow fit, 25 mm diameter directly, and we'll do the whole installation of this house in Geberit flow fit. So I put a Teflon seal inside, and here, there we go, we tighten it. Let's imagine it's tightened properly. I can still turn the ring to tighten it, so for that, it's really practical. We'll make 2 90-degree bends. So I put a clamp back here. You'll see that I messed up here. I shifted over because actually it just fits with the EcoBowl system, but I missed it by a few centimeters. It's not a big deal. Anyway, there's a cover here so you won't see it. And I'll just touch it up with a bit of paint. I've already patched it up anyway. That's the main thing. So here, the multi-layer. There we go. We fit it in there. I tighten it behind the lock nut. We try to position it like this and we screw it on top. A press fit valve, and for those who are wondering, of course you can do maintenance on this valve. We remove the blue cap for cold water and use a red one for hot water. You access a screw, you unscrew it, you reach the ball of the valve so you can do your maintenance. We're going to press fit it directly, and that's my valve. So now the water flows, I close it, I shut off the water to the whole house. The ideal thing, if you're going on vacation, is not to shut off the water inside the house, but to shut it off at the street. You shut it off at the street and you're at ease. Next, on the top, we continue. Hop to the eco bubble system, and it's always handy to have a valve here. I placed it at a specific height, considering people with reduced mobility and the elderly. If you have a bad back, I would have preferred to place it higher instead of at ground level, but I could add an extension. Still, it's useless. It's for the big garden bins, but you might need it. See, so you'll be happy to have it at the right height, my little box. I'll open it and do a quick dry run for you. Next, we proceed with installation. We start with the Jebbery flow fit, diameter 25, and its fitting, and from there, everything I'm showing you. Everything is included in the box and caboodle, except the carbon monoxide, 2 bottle. You will get one from your preferred supplier, so from there, as I told you, everything is provided. A pressure reducer, a 3/4 to 1 inch adapter, which is also included, the carbon monoxide, 2 carbonator, and its little cover. We'll put it on once it's installed. We have a pulse meter, a supplied free nut connector, the filter, the wrench to remove the filter holder is included, of course, the filter, and from there, you go back out to your installation. For me, it's the Jebbery flow fit, but it could also be cross-linked polyethylene or copper, sink, kitchen sink, shower, toilet, and of course, the water heaters above. We have the control box, the control unit, the connection box, the gas module to connect to the bottle, and this module we will connect it to the carbon monoxide 2 carbonator. It comes with a small chain and fasteners to prevent the bottle from tipping over. A tester to measure the water before and after, and a sleeve to put on the bottle. And a bit of reading, well, it doesn't hurt. And here you have the EcoBowl system ready to install. So this is the installation with the pressure reducer that comes from the EcoBowl kit. Make sure you don't already have one on your installation, especially outside. At the water meter level, so on top 3 bar C, you can increase or decrease the pressure. Of course, here we're going to put the Geberit flow fit fitting, which is already clamped at the threading. So we'll need to make it watertight. And on the other side, 3/4, so 27 to 1 inch, since after that, the rest is 1 inch, okay? So, to make it watertight, like I told you, my fitting is already scratched, this one isn't scratched. So, either you take a hacksaw blade, even a box cutter can work, and you scratch your fitting. You could use these pliers, though they're pricey. I'll include a link in the description for you to check out. And all we have to do is go around it. So these are small serrated rollers that crush the threading. The advantage of scoring it is that the sealant you put on it won't spin around the thread anymore. That's important. So it will grip onto the threading, and we're going to use Tangy Unilock, so nylon thread impregnated with silicone. The advantage of this is that it's removable. It's easy to put in place. It's clean. You don't need a ton of consumables, and all you have to do is fill the threads. We go around like this again, then we're gonna cut it here and tighten it like this, pressing it down well. So from there, you have a connection that's 100% watertight and removable. So I'm going to do the same thing for him and for a valve that I'm going to install on the filter. So here, I'm going in the right direction, finally in the right direction. By tightening the fitting, of course, it will tighten the Tangy Unilock. If you wrap it the other way, tightening it will loosen it. Okay, so now we tighten it well, and now this one will go here. And this one I can still adjust its direction so I can tighten it like this, like that, it doesn't matter. I come in with the flow fit, and here we continue with the carbon monoxide, 2 carbonator, and the rest of the EcoBowl system. So here I'm at 1 inch. This is where I messed up. I drilled and shifted it for some reason. When measuring, it's not a big deal. There we go, the pressure reducer. Earlier we installed the fittings on it with the seal, so Teflon joint inside the carbon monoxide, 2 carbonator. We're going to install it on him. So this one, it's going to come here. And next to it, we'll put the pulse meter, always with the little gasket that fits well. So here I'm putting the little 90-degree fitting. There's also the Teflon gasket inside. A little bit of a thin layer and we get to the filter. Earlier we put in the fittings, the flow fit, the valve, and this, we fix this into the wall. We're going to start crimping. FlowFit's advantage is that you can rotate it in any direction to crimp. On top, underneath, in front, behind, it doesn't matter, we have indicator windows. You make sure that the pipe is properly inserted and the other one as well. The advantage is that we only have 2 jaws for the whole range here. It's blue color, blue jaw. I go from 16 to diameter 40. We position ourselves like this and press. The advantage of the indicator that comes off is that I know my fitting is crimped. I screwed directly into the wooden reinforcement I placed next to the water heaters. For those who recall, I installed 2 reinforcements. This one is wood. Behind the drywall, I screwed directly into it, and now I can hang things up. If I find the right spot, it's here. I went too high. There you go. So now I can hang it up. We'll be able to connect it. I'll connect it. So in the box, we have this little piece that lets you disconnect the wires if needed. So you see, a minus plus CC, E minus, E plus PP. Well, that matches what you have on each plug, so E minus, E plus. We'll connect it to E minus, E plus P, P with P, and C with C. Okay, so now we just need to put all of this in there. So what I'm going to do is I'm going to change it. Yes, we're going to remove it. We're going to put it here. I'll make sure it stays put by placing it at the bottom. We'll put him here. Hop, so what's this? Is it minus and plus? So see? Hop, it comes here, so E minus, E plus. And without a closed port. I put everything behind. And we connect it to the bottle. On the carbonator, we can put the cover on so it looks neat, and then we'll connect the carbonator to the bottle. We put this on, we press, and if we need to remove it, we press the green ring and pull it off. I managed to do it. There you go, just like that. And so we're going to connect the carbonator to the gas module. Quite simply, there you go. Everything is plugged in, everything is connected, except for the control box. I need to add an outlet, but for now, we'll use an extension cord and leave everything hanging. We need to install the water heater, hot and cold water. It will go in every direction. So I prefer to put my multi-layer pipes in first and then see what space is left. We'll put a duct to hide all that, but I prefer to install my multi-layer pipe first. If you install your duct first and it's neat but later blocks the multi-layer pipes needed for everything, it becomes complicated. So prioritize the multi-layer pipes. We're going to turn on the water, fill a bucket, and we'll be able to test the water. So we'll take a measurement before and after. For now, I'm filling my little bucket. So, you understood what this is? For the garden faucet, for now I've put in a flexible hose and then we'll move on. That's it. For now I'm not going higher. I want to provide hot and cold water, the water heater, etc. first. We'll deal with the garden faucets later since they're not important. I want to tell you, okay? So, there you go. I went to turn the water back on in the street. Of course, we'll fill a bucket for now. I'm opening it slowly. There we go. We'll open here as well. And we'll take the opportunity to check that it's not leaking everywhere. It seems pretty good. And normally in there, yes, it's filling up, you see. So of course you have to close it, otherwise it's going to leak. There we go. We can open it. We'll let all of this fill up, same for the bucket, and we'll pick up again when it's full, once the bucket is filled. We take the tester's box with us. You have the instructions, of course, and with the EcoBuild kit, the little chart, we'll refer to it in a moment. Okay, so the tester, here we go. We open it, we press on it, so 100% battery, that's perfect. We turn it off, we keep our finger pressed on it. It goes into calibration mode. We take the first solution, the green solution. There we go, we dip it in, and we need to reach a value of 4. That's good. So we take the second solution. We dip this in there so it blinks. Still in calibration mode, it records, okay, so that's good. And now I dip it in there and we wait to see what happens. Now, it's going up to 6.7, 6.8. We have to wait for it to stabilize. Okay, it seems to be stabilizing at 8, so we'll stick with that. Let's open the bottle. Here, same thing. The idea is to set it to 1 bar higher than the network pressure. If you have 2 bars, you set it here to 3 bars. If you have 3 bars on your network, you set it to 4 bars at the level of the bottle. So here I have 2.5 bars. I'm going to set it to 3.5 bars. There you go. The magic chart on page 25 of the manual, included in the EcoBuild kit, adjusting the opening of the micrometric screw based on the initial pH and the water hardness. For example, a hardness of 20 and a pH level of 7.4. Well, you set the micrometric screw to 3.5. The micrometric screw is located on the bottle. We'll check that soon, so depending on your result, use this table as a reference and unscrew the cover. We have a micrometric screw per the table. I know, I need to set it to adjustment 5, so the more you unscrew... Here, for example, I'm at 6, we could go up to 8, for example. So by screwing it in, I'll obviously reach number 5, which is between 4 and 6. Right here, there you go. It's a precise adjustment. We put the cover back on. That's it. Here, normally it should blink if I draw water. It's working well, and the carbon monoxide, too, is being injected properly. On the control unit, we have plenty of options like the dot or non-installation setting. Change the code. By default, you have a 4-digit code, and of course, you can change it. Then, we have solenoid valve opening time, leak detection, new bottle, delete water consumption, factory configuration, general info, save data, update, and restart the system. It's very comprehensive. As I said, I need to run all my multi-layer pipes to connect the water heaters and lead them to the house. All wiring will go in cable ducts. We'll look at that later. I also need to run an outlet because right now I set myself up here, but I'm going to put an outlet right next to it. But as for the EcoBuild system, it's done. So we have the control box, the pressure reducer, the carbon monoxide, 2 carbonator, the pulse meter, the filter, and of course the bottle. We can keep going. I need to remove the hose I used to draw water. I had connected it here and like that. Did you see it was blinking? Alright, so now we'll continue with the booster pump and then move on to the water heater. But who's drawing water? When I shower, there's no pressure. Everyone's experienced it or caused it by using water while someone else is showering. Someone yells in the shower due to low pressure from a sink, wash basin, or toilet flush. To prevent this, there's a solution called a false drop. Scala 2 is a booster pump system. You can also use it if you have a well, for example, and you want to draw water to supply your house and therefore get more pressure. Well, the Grundfos Scala 2 is made for that. In this house, we have a pressure problem. Sometimes there's no pressure at all. And at the very most, I have 2 bar, 2.5 bar. I noticed with the kitchen livers that sometimes water pressure was low when filling pots or washing my hands, sometimes a trickle, sometimes normal, and other times nothing. And then after that, it would come back. False alarm. Scala 2 is here to save your life. So it's going to increase the pressure, but there's no point in putting 6 bars in a house. Household appliances won't like it. Setting it to 3 or 3.5 bars is more than enough. 2 or 2.5 bars is also very good. For the garden, that's enough to water plants and fill a bucket. Very good. If you want to wash a car, clean a patio, you use your pressure washer. For the house, 3 to 3.5 bar is ideal for comfort. And above all, it will stabilize the pressure. You'll have constant pressure, no matter what happens. If someone is showering while another uses the sink, kitchen, or flushes the toilet, there will always be the same pressure, so that's true. It's a comfort. So the big advantage it has is that it's a fully automatic, compact, and quiet pump. Look, I'm holding it in my hand. It's quite light. We're going to fix it to the floor, of course, and we need a small outlet to connect it. You have the little manual on the box, you have instructions. Honestly, it's so easy to use that you don't even need the manual, and it's easy to install. Here are the water inlet and outlet, and you can use them even if your supply comes in at an angle. You can adjust it, you can direct the water inlet and outlet. Okay, so the tank is built in, we have the float, the sensor, everything is integrated into this pump, and of course the motor is inside. You see how much space it takes? It really doesn't take up any space, and on top of that it's ultra quiet. So if you're in a home and you have no choice but to put it inside the house instead of the garage or an annex, it doesn't matter, it won't make any noise. It's 1 inch. I have Geberit fluffy fittings, 25 mm of diameter with a captive nut in 1 inch. We're going to install them underneath the Grundfos Scala 2. Well, of course, you'll have the link in the description. We're going to put this mat and also the link in the description. This kind of mat is great. Put it under a washing machine, under a compressor, and it prevents it from vibrating. So of course, she had secured it to the floor. But if your fastening is not tight enough and there's a washer that's vibrating, you're going to hear it. So you put this kind of mat down and you tighten everything properly. So this one is ultra quiet. It's perfect for indoor use, but it's your fastening that could cause a problem. That's often the case. It's never the machines. It's usually the fastenings that aren't tightened properly. So make sure everything is tightened well. Installation is quick. Lay the mat, place it on top, make 4 holes and fasten. And everything is integrated into this pump. So the motor, the sensor, the controller, the reservoir, the valve. We're going to put a little bit of water in it to prime it. We'll see that in a moment. It's self-adaptive. On the top, we have the control panel. Of course, we're going to plug it in. You'll see that. And it will automatically adjust according to the pressure. So it's economical. This pump features a variable speed motor with built-in protections against overheating, low water, and more. So the Grundfos Scala 2 is ideal. If the water comes from the city network or a well, you'll gain in comfort. Now that it's fixed to the floor, I can put on my fittings. Here, we're using 1 inch, and of course, the gasket is inside. I'll tighten that in a moment. We do the same thing here. We take the multi-layer pipe that I bent for the occasion, we put it there, we close the little clamp. And so we end up here at the valve. I hold the gasket that's inside at the same time. So here we put the same fitting as on the other side. And now I'm going to head toward the manifolds. We're still going to put in a valve. The new one, we pass it through the clamp. Manifold. 3 outlets that I can extend if needed. I could have put a 4 outlet, a 6 outlet, but honestly, 3 is more than enough. Water heater, house, garage, and then, as I told you, we can extend it, so 3 outlets are enough for me. Of course, I need to tighten all of this, but for now, we're going to do the crimping. And this one, I can open it, so I'll have to tighten it as I told you, this one. It fits, it's perfect, and then here, we can close it. So before plugging it in, so we're going to remove this cap and pour 1.7 liters of water into the pump. We close all that back up. We're going to open it as well. And here I have a hose that goes into the bucket. That's normal because we need to draw a little bit of water, so I'm not going to use a lot of flow. It's just so it can run. And now that we've put in the water, well, we can plug it in. I'll leave the extension cord for now. We'll handle the outlet later. So now we let it run. It's working for now. Now that the Scala is secured, connected, filled with water, and plugged in, it's ready to operate. Installation is fast and simple. The dashboard is intuitive with an on-off button and a blinking green animation. It's all very nice. Arrows to increase or decrease the pressure. I'll set it in the middle at 3.5 bars. That's enough for a home. I lock it by holding both arrows. The padlock is steady, it's locked, and there's a reset button. There are icons numbered 1 to 7. The first one indicates an electrical failure. Number 2, the pump is blocked. Number 3, it detects system leaks. That's great. Number 4, there's a lack of water, so the pump is running dry. Number 5 is maximum pressure exceeded. Number 6 is maximum operating time exceeded. And number 7 is overheating. The pump will enter safety mode to prevent minor damage. And here, just like on your car or bike tires, there's a valve. You remove the little cap and you can refill the pressure. What is this? It's ultra simple and compact. Now we'll add water and you'll see it spin. Here's our cold water tank. I removed the hose, so there's some water on the floor, but it'll dry. One line goes to the water heater, another to the house, and a third to the garage. And of course, we can extend it for now. I put a cap on it with the proper little gasket. So the first line going to the thermodynamic water heater is behind me. I'm going to bring it back from the thermodynamic water heater. So we go into the 50-liter water heater, and then we come out of the 50-liter water heater. To supply the hot water manifold and the hot water manifold, we also need to create the domestic hot water recirculation loop at the 50-liter tank. I'm going to put in a T-joint, and we'll manage with all of that. Thermador X-Cross multi-position safety group 3/4 20-27. We have two, one for the thermodynamic water heater and one for the 50-liter water heater. I'll show you what it looks like. So for now, they're both in a horizontal position, so we can, of course, orient them in any direction we want, right? That's an advantage if your power supply comes from below or above, okay? For now, they're both in a horizontal position. So for the thermodynamic water heater, that's the setup I need. Now for the 50-liter one, I need to switch it to vertical, and for that, it's very simple. You take a screwdriver, we remove the clamp, we remove the second one, we take out the valve, we remove the cap, we put it here, and the valve goes there. Now I have my safety group the right way. For the 50-liter water heater, use a vertical position. For the thermodynamic water heater, use a horizontal position. So you have one reference, several possibilities. We don't complicate things with 50,000 safety group references. Your advantage is for maintenance. Whether it's in a horizontal or vertical position, you just have to change the valve. You change the valve, that's it. The advantage is at the level of this cap, whether it's horizontal or vertical, it's exactly the same. I could come and put a specific fitting, which I'm showing you, and I'll also put the link in the description. And we start again with a thread. So it's pretty practical for an expansion tank or to create a domestic hot water loop. You connect directly to this fitting. So this one will be used for the 50-liter water heater. I'll put the cap back on. And there you go. Thermodynamic, 50L vertical, horizontal. So we remove the little collar, and of course you'll have to put it back if you forget to put it back. You've installed your safety group. It's not a big deal, but it looks nicer. So for sealing the safety group, always use Tangent Unilock. It's a safe bet. It works everywhere, so you take a small piece of thread and fill all the threads by applying a little pressure on the thread. So now we can go back to the starting point. We cut off the excess and we tighten it. Here, you see that I'm tightening in the right direction. If you wrapped it the other way, when you tighten, it would actually loosen the thread. So we take our collar back, we put it back on. So my safety group is in a horizontal position. Now we can install it on top. Here we're good because my water inlet will come on top, so we're aligned, we're good, and so it's on top. We place the fitting into the multi-layer pipe. I'll show you what I did. I put the gasket in, and then we smooth it here. So this one is properly fitted. I put the fitting into the multi-layer pipe. I put it back into my clamps. The gasket, we line it up. For now, we'll tighten it by hand. You have to make sure it's properly seated. I bent the entire 25mm multi-layer pipe from this manifold, as you can see. This is my water heater's cold supply. Closing this valve shuts off cold water to the heater. Nearby are the house, garage, and we can expand the manifold. Everything is bent, saving on fittings, and since I have space, I might as well enjoy it. And we arrive at the safety group, and I also have a small valve. I'll need to crimp should I add a threaded rod clamp anchored in the slab. I need to do it for the drainage, so I could redo it for the multi-layer pipe. But anyway, there are enough clamps. It's holding. It's not going anywhere. Okay, so the drainage will go behind this bottle, under the multi-layer pipe, and near the 50-liter water heater, it will go behind this multi-layer pipe. That's why at this panel, we're more offset than at the back panel, because it's going to go over this panel. Here, it's connected to the water heater pipes and to the drains that are in my little hatch. Okay, so now we're going to focus on the hot water. We're going to run under the 50-liter water heater, go into the water heater, come out of the water heater to supply the hot water manifold. And so for the hot water, we have an electrical connector that comes with the water heater, and there's a gasket inside. I'm going to put exactly the same fitting as I did for the cold water, except I'm not sure if I should put it this way or that way. Normally it should fit like this, but I'm not sure, so I won't tighten it for now. We'll see about that later. So on this side, it's supposed to be the cold water that goes into the water heater, the cold water supply. My thermodynamic water heater will provide and deliver hot water here. So that's why there are two electrical connectors. And here I'm setting up my awesome assembly. You saw me do it. I showed you in fast forward. It's the Thermador X-Cross safety group, like on the thermodynamic system, but here it's vertical and I added a T. Here we have a check valve that allows water to flow in the correct direction to prevent problems. This could be a valve, an expansion tank, or my domestic hot water recirculation loop. So either an expansion tank, a domestic hot water recirculation loop, or an expansion tank with a domestic hot water recirculation loop. But in my case, the domestic hot water recirculation loop will come here, so the pump will be on this side. I'll tighten that later. Earlier I was telling you about the water heater. I don't know if I should put it like this or facing down. In the end, it'll be facing down and I'll go back up to the water heater. And here it'll be simpler. If I put it like this, it's slightly off and tilts, which I don't like. So I put it in the clamps, we fit it in there, and we do the same thing here. There we go! When I run the multi-layer pipe behind, we put the fitting on, we check that it's properly inserted. I run this through my clamps. The gasket. So we do the same as with the cold water manifold here. This will be my hot water manifold, the fitting, the gasket, a valve. And so here I have my hot water supply for the house, my hot water supply for the garage, and a supply that could be used for, I don't really know what. And here we can extend the manifold, just like I can extend the cold water manifold. So for the hot water as well. Well, that's it. It's done. Let's send it. Here is the real-time sound of the Scala 2 currently running at full speed, because we have to fill the 240 liters of the thermodynamic water heater, and of course then the 50 liters of the buffer water heater. I'll let you listen. Air is in the pipes, the water heater and the 50-liter water heater, so we must do the same procedure for all. You run a little water and it pushes the air out. I skipped fixing the boxes in the drywall for you. Just put screws in all directions and they'll hold. I ran 3G-25 wire to supply the heat pump and the 50-liter tank, so neutral with neutral. I'm connecting the ground wire, but for now it's not connected to the panel. And for the small 50-liter water heater phase with phase, neutral with neutral, and ground with ground, we put all of that in there. So on the panel, I brought the lines. This is the thermodynamic water heater. On the 20 amp next to it is Eco Bubbles. Here are the power outlets. On 16 amp, the garage power outlets. Next to it is the lighting, where we take the neutral from the thermodynamic water heater. We put it on the neutral terminal, and the phase, we make a small loop and put it next to it. And so Eco Bubbles, the neutral, and the phase. On this line, we do the same. Here I have a 20 amp for the 50-liter water heater. And then next to it, we'll put the Grundfos Scala 2 pumps. And here, this will be for the domestic hot water recirculation. And next to it, the gate, so the neutral. We put it here. There we go. So this is the 50-liter water heater, and the phase is right here. Well, it's almost done. I say almost because for this installation, it's perfect. However, for the electrical panel, I still have quite a bit of work to do. The outlet for the Scala 2, the outlet for the pump, the hot water recirculation loop, the gate to connect, the ground rods to install, and connecting all the grounds. I labeled everything to stay organized and close things up, so there's still plenty to do. We'll see that in a future video, but for now, I also installed an outlet. For Eco Bubbles, 2 junction boxes, the water heater, power supplies, a small cable duct to hide the wires, Deco Bubbles. I could shorten this one, but if we ever need to move the Eco Bubbles, we'll be glad we didn't. To have some extra length, so in terms of electrical outlets, etc. It's not quite finished yet, to be honest with you. I don't know where to put the outlet for the Scala 2 since I wanted to install a sink, so I'm going to install a sink. But if the owner doesn't want to reroute it into the garage, I would have made holes in the drywall for nothing, because I want to put it on a bracket. So I thought I'd create a structure with steel angles, put the sink on top, and if he likes it, well, we'll fix the angles directly onto the drywall so the sink won't move anymore. If he dislikes it, I can remove everything without causing damage. The drywall and the outlet will set it up either here or against the cable duct. We'll see. It depends on the mood, the structure I want, and if Sil keeps the sink. So while the water heaters were filling up, well, I took the opportunity to do the drain lines. Glued 32 AMAC polyvinyl chloride from this safety group. We go in this direction. The condensates also flow into it. The 50-liter watt heater well, it's the same safety group. There, it flows into the polyvinyl chloride, and then we get to Geberit Silent PP, 40mm diameter, so this will be the sink drain. We go through my little hatch. I'll show you what I did underneath. So, for those who hadn't been following, I had cut the slab, dug, removed a lot of dirt to fix the drain, because outside everything was blocked, so I redid the drains. Geberit polypropylene 90mm diameter to start fresh in the house and create something clean. So, of course, you have the playlist link in the description, but that was the episode. I don't remember which one. I'll show it right here if you want to check it out. And now I'm going down into the hatch, and basically, here's what I did. So here, we're heading towards the house with a 90mm diameter. That will probably be the next episode. Right now, I have extruded polystyrene on the ground with a fitting to hold it, but I'll need to add a concrete slab, threaded rod, and clamp. We return to a 50mm diameter using a 50-40 reducer to reach a 40mm diameter. And then, as you understood, the water heater drains, and here, I can take everything apart. So it would really make sense to take everything apart. I don't know, but at least we can. And for those who are wondering why this is here, it's because I want to put in a vent, and the vent, I could remove it and use a drain snake if needed. But you'll understand, if you haven't seen the episode, go check it out. It was a disaster. The drains in this house, so the water heaters are now full. How many liters did we pump out? We pumped out 316 liters, 240 liters, 50 liters, and 290. I filled a few buckets, totaling 316 liters. The count is correct. Did you understand this setup? So we start from the main cold water supply, going to the garden, to the house. We go through the Eco Bubble system, we reach the booster pump, and we come out of the booster pump. Cold water manifold, I supply my water heater, it heats up, it sends hot water into the buffer tank. Okay, it goes in, it comes out to the hot water manifold, so now we can send cold water into the house. I'm going to make a kind of bayonet connection. I'll make a hole here and run it into the house, and I'll do the same for the hot water, a kind of bayonet connection for the pipe, and run it into the house. Here, we'll reconnect to the domestic hot water recirculation loop. I'm going to set up the camera. We'll look at the menu of the Thermo Aeromax 6 because it needs to be configured. You can pick any language, Italian, English, Spanish, but we'll stay with French. Just a few more steps to configure the system. Continue. The system automatically switches to summer-winter mode at Linical. So here, it's asking me for individual ducting, outdoor. No, for us, it's not that semi-ducted configuration either. We don't have any ducting, since the volume allows me not to use ducting. Is a control signal connected to the terminals? No. The system is allowed to operate only when necessary during the programmed periods. So, there you go. That's interesting. Depending on your electricity provider, depending on off-peak and peak hours, we can program when the water heater heats up. So right now, it's set from midnight to 8 a.m., but I need to check according to the contract. But you can set, for example, 11 p.m. to 7 a.m., 10 p.m. to 6 a.m. That's according to your electricity provider. So here, if I press OK change day, copy day, we can copy, of course, change and confirm. The whole week, let's go. The system should minimize use during electric peak times to ensure enough hot water. That's great. The Eco manual, I'm going to set it to manual 55. We're going to increase it, you see? Degrees. The system is ready to start. Okay, should we start a boost cycle right now? No, because I already did it. Honestly, I started the boost cycle, which means forced operation. If you just installed it and need a shower soon, use boost mode to heat it up quickly. So no, and now it's running. And so, after that, if we want to go check in the menu to see what's hidden, we have the absence mode, we can check the consumption, the date and time settings, and the heating schedule. That's what we saw earlier with the time when it will start during off-peak hours, the electric booster, the Wi-Fi. So of course, you can connect it to Wi-Fi. There's an app to download if you want to control it through the Notice Access Expert app. Be careful, this is cork without a reservoir, qualified personnel only. Continue. Diagnostics, backup mode, software version. Of course, you can reset it. External anti-Legionella control. That's interesting. As well as every 4 weeks, I'm going to set it to 62 degrees every week. We kill the microbes. The electric booster, that's what we saw, the type of installation, whether it's semi-ducted, ducted, etc. The thermodynamic system feeds the 50-liter water heater, which outputs at 60.5 degrees. It's perfect for killing microbes. I could lower the dial to 40, 45, 50 or 55 degrees. At maximum, it's 60.5 degrees. Printing the sticker label that I'll see about, it depends on what the owner asks me. We could also put a thermostatic mixer underneath there. The process would be to say, okay, this one heats up Maxime, and underneath we set it to 50 deg. For example, that could also be done, but we would lose a lot of space. But it can be added anyway. So this one is set to 62 degrees. It's going to heat up at full power once a week. Let's imagine that the owner doesn't use it for, I don't know, he's not there. For 3 weeks, it cools down in the tank and it's going to heat up once a week at 60 degrees. To kill the microbes, that's very important. You have to think about it. There are a lot of people who don't do it. But your water heater ends up full of microbes. They say to themselves, I'll set it to 50 deg C to save money. But yes, but microbes aren't great in a water heater. So keep that in mind. Next video, guys, we're going to look at 90mm drain pipes. And that's the most important thing in this house, because the water supply lines, I can run those through the attic. From the manifolds, boom, we go into the attic and I redistribute through the walls. Bathroom, kitchen, etc. But for the drains, I have to access them through the crawl space. Once the floor is installed, that's it. I don't have access anymore, even if I have a great hatch here, if I need to access the crawl space. Whether it's me, another tradesman, or the owner, we'll need to dig through the dirt to reach it. So, I want to think about as many things as possible when it comes to the drains. That's what we'll see in the next video. And once we've installed the drains, toilets use a 90mm diameter, while showers, cabinets, sinks, and the kitchen use 50mm. Once the floor is installed and sealed, everything is closed up and I lose access. So, we're going to plan for several drains for the kitchen, and we're going to install 90mm drains in the cabinets around the bathroom so we can use a drain snake if needed. If one day we need to intervene, I could also remove the toilet bowl. We could also go through the attic via the toilet vents. But if I have access, like small inspection hatches or caps with vent noses on them, we'll see. What we put in, we take out and put a drain snake in there. It's not a bad idea. And it allows you to unclog a pipe without worrying about it. You have to crawl into the crawl space, then remove some dirt and cut them. Check what's wrong. Drains can clog, especially with kids who throw things in. It's happened before. So, there shouldn't normally be any children in this house, from what I can see. But let's imagine a child takes a whole roll of toilet paper, puts it in the bowl, flushes 15 times. That's happened before. It can clog a pipe. And then, to unclog it, it takes time. You have to get the drain snake, and it can be really annoying to unclog. So you really need to put in access panels, clean out plugs everywhere so you can unclog a pipe all along the way. Like I did with this little access panel, you saw it. I put in a vertical outlet like that so you can insert a drain snake easily. I'll cover the rest in the next video. We close up the floor, and once the floor is closed, we tackle the ceiling because I can bring in the drywall lift, so the ceiling, marking for insulation and ventilation. We can put up the drywall, then we can install the metal stud partitions. We drywall one side, the side where I have my water supply lines. We run the multi-layer pipe down. We drill directly for the fixtures, the mounting plates, everything that needs to be fixed. It's easier than running the multi-layer pipes straight down. And thinking now, I have to put up the ceiling, it's in my way, I have to put up the partitions, my multi-layer pipes are in my way. Now that I have my panel, I need to drill in the correct spot before installing it. The simplest way is to put up one side of the partition first, and then run the multi-layer pipes directly through the partition. You just say, okay, I want to drill here, boom, you drill, you go through, it's much simpler. Okay, so, next video, drainage and flooring. We've made good progress in this video, so I'll see you in the next one. Like I said, with the drainage and the flooring. In the meantime, work well, take care, and see you very soon.